Greetings, Dr. Dan with Optimal Optics, here to introduce Unit 2P. We all remember Hamlet's famous soliloquy, 2P or not 2P, that is the question. Shakespeare was inspired to write that when he woke up in the middle of the night and wondered whether he should get up to use the chamber pot. Shakespeare also wrote the play Julius Caesar, and we all remember what Caesar famously said after he was stabbed by Brutus and the other Roman officials. Ouch! But I digress. Back to optics. So we're going to go over some word problems about light as a particle, which we learned about in Unit 2, which I assume you have already viewed. If not, this would be a good time to do so. Please remember that this is an optics course. It's not a math course. So if the math confuses you, there are links in the comments section, one to the Khan Academy for online courses, or you may contact me via email and we can arrange for online tutoring with me if that's what you'd like to do. So, question 1, what is the height of a tower which casts a shadow 160 feet long when a vertical rod 3 feet high and exposed to the same light source casts a shadow 4 feet long? So you should pause the video, try to solve this yourself before you see how I do it. So, it usually helps to draw a picture first and enter the information that the problem gives you. The vertical line is the tower. The horizontal line is its shadow. The smaller vertical line is the rod. So we do not know the height of the tower. That's x. The length of its shadow is 160 feet. Height of the rod is 3 feet, and it casts a shadow 4 feet long. So you see we have two similar triangles, the very large triangle and the smaller triangle on the lower right. And we know that they're similar because their corresponding angles are equal. So we set up our proportion, and we find that the height of the tower equals 120 feet. Question 2, an object 6 inches high is placed in front of a pinhole camera at a distance of 6 feet from the aperture. What is the size of the image on the glass screen if the length of the camera is 1 foot? Express your answer in inches. So we'll draw our picture. We'll start with a pinhole camera with a small hole. And then we'll draw our object. The object height's given in 6 inches. So what we'll do is we'll convert that to feet. And then when we're all done, we'll convert back to inches. This way the numbers that we work with are smaller and easier to deal with. That's the light ray from the top of the object. That's the light ray from the bottom of the object, forming its image on the back screen of the pinhole camera. So 6 inches is 1/2 foot. The distance from the object to the pinhole camera is 6 feet. And the pinhole camera is 1 foot long. That's the upper light ray, the lower light ray. These two triangles, the larger one on the left and the smaller one on the right, are similar. They have equal vertical angles and equal corresponding interior alternating angles. So we can set up our proportion. X is the height of the image. And we find that x equals 1/12 of a foot, which equals 1 inch.